Good morning, students. Myself, JNTUK from EC Department, Chevrolet Engineering College. Today, we are going to discuss about the remaining examples in the Fourier transform. The last class also we discussed about some examples in the Fourier transformation, that is exponentially decaying function and exponentially rising function, and exponential function is e power minus a, the magnitude of t, and the Fourier transformation of constant. Okay. Now we go for some other examples. So we got the a into e power minus at, a into e power minus at, the Fourier transformation of for meanwhile for our confusion is remove this a, the x of at. Let us take here. Let us example 1. Take the x of t is equal to e power minus at mu of t. E power minus at mu of t. So what is a Fourier transformation? Find Fourier transform. Okay. So definition of the Fourier transformation saying the x of omega is equal to integral minus infinite to infinite x of t e power minus j omega t dt. That is equal to integral minus infinite to infinite. Substitute the x of t is e power minus at mu of t e power minus j omega t dt. X of t is exponentially decaying function, and we know the mu of t is equal to 1 for t is greater than or equal to 0, and 0 for t is less than the 0. For negative values of t is a 0, and positive values of t from 0 to infinite, the value is 1. So change the limitations from 0 to 1, 0 to infinite. E power minus at, the mu of t is equal to 1. So both here the bases are the same. E power, take the t is a common, a plus j omega. A plus j omega into dt. Since the mu of t is equal to 1. Mu of t is equal to 1 for t is greater than or equal to 0. Apply the integration for the e power minus at, nothing but e power minus t into the total function, e power minus of a plus j omega whole divided by minus a plus j omega is the coefficient of the t. Now the upper limit is infinite and lower limit is 0. After substituting the upper limit, it becomes a 0. The lower limit is minus into minus here, the plus will get. E power 0 is a 1, and denominator is a plus j omega. Therefore, e power minus at mu of t, e power minus at mu of t, the Fourier transformation is 1 by a plus j omega. 1 by a plus j omega. Got it, madam? Similarly, you can take the exponentially rising function. For the x of t is equal to e power plus at mu of t. Plus at mu of t. What is the find the Fourier transformation? Find the Fourier transformation. Here also I am substituting in the directly the x of omega is equal to integral minus infinite to infinite. I am writing as a 0 to infinite by substituting mu of t is equal to 1 with the e power at and e power minus j omega t dt. Okay. That is equal to integral 0 to infinite e power, take the minus t as a common, a, let it is a minus t, the a e power a t, a is a minus, so take the plus only, the a minus j omega into d, a minus j omega. That is equal to, so e power minus j omega and e power a t. So e power a minus j omega into t will divide by a minus j omega. The upper limit is infinite and lower limit is 0, is equal to substitute here, or otherwise you can take it as a directly, it is a minus also, j omega minus a, j omega minus a. Now the upper limit you can substitute 1 by a minus j omega e power 0, e power infinite minus e power minus 0. That is equal to minus 1 by a minus j omega. Therefore, the e power at mu of t the Fourier transformation, e power at mu of t, the Fourier transformation is minus 1 by a minus j omega, a minus j omega. The rising function and the decaying function. Decaying function is 1 by a plus j omega, and the rising function is minus 1 by a minus j omega. And similarly, for another example, you can take it is in the last class also we discussed minus a magnitude of t. The x of t is equal. Find the Fourier transformation. Find the Fourier transformation. So the x of omega is equal to integral minus infinite to infinite. I am directly substituting here the e power minus a, the magnitude of t, into e power minus j omega t d. See, for the t is greater than or equal to 0, for t is greater than or equal to 0, it becomes of e power minus at. The x of t is equal to the magnitude function, and e power minus into minus the plus value, the e power at, t for less than the 0 values. So the x of omega is equal to, we got minus infinite to 0, e power at, e power minus j omega td, plus the integral 0 to infinite, e power minus at, e power minus j omega td. Okay. Then, what is the integral here? We get the e power, take the minus, not the minus, take the t as a common, a minus j omega. The upper limit is 0 and lower limit is a minus infinite. It is a minus j omega. And for the second integral, e power minus t can take as a common, a plus j omega. After applying the integral here, a plus j omega, you will get in the denominator. The upper limit is infinite and lower limit is 0. The first term, substituting the upper limit e power 0 is a 1. So 1 by a minus j omega. 1 by a minus j omega. For the positive, the exponential is a positive value. Plus, and for the lower limit here, e power minus is there, and here also the minus term. It becomes of 1 by a plus j omega. 1 by a plus j omega. To simplify this function, denominator becomes of a plus b into a minus b is a square minus b square minus j square is a 1. So it becomes plus 1 a square plus omega square. So a plus j omega plus a minus j omega. J omega get cancelled. And this is x of omega is equal to 2a by a square plus omega square. The Fourier transformation of the e power minus a, the magnitude of t, the Fourier transformation is 2a by a square plus omega square. Okay. Now, for the exponentially decaying and for exponentially rising function and the magnitude of the t, the time domain function, we'll get the frequency domain function x of omega is equal to one thing is a 1 by a plus j omega is 1 by a plus j omega, and is a minus 1 by a minus j omega, and for the magnitude 2a by a square plus omega square. Okay. So 2a by a square plus omega square. Now you could go for the constant function. Before going to the constant function also, now let us see the Fourier transformation of t into e power minus at mu of t. When you can multiply the t, the function already we find out the e power minus at mu of t. What happens? Okay, I will explain here. See, for e power minus at mu of t, we got the 1 by a plus j omega, and e power at mu of t, we got the minus 1 by a minus j omega. Then you can find the Fourier transformation of the x of t signal is e power x of t is equal to t into e power minus a t mu of e power minus a t mu of t. Got it, my students? Find the Fourier transformation. Find the Fourier transformation. The t is multiplied now. For the first example, we discuss now the e power minus a t mu of t is e power minus a t mu of t. Its Fourier transformation is 1 by a plus j omega. We got that. Now, what is a Fourier transformation when it is multiplied with the t? So let us see the x of omega is equal to, directly I am substituting minus infinite to infinite t into e power minus t, can take as a common a plus j omega into dt. Now it is in the form of integral uv. The first of all, you can take the t integration by parts, apply the integral of second one. This is e power minus t a plus j omega whole divided by minus of a plus j omega minus, it's a whole multiplier, students, minus Apply the derivative of t. The integral of apply the derivative of t is 1. And again, you can apply here the integral of this function e power minus of t into a plus j omega whole divided by minus of a plus j omega not from minus infinite is a 0 to infinite, my students, because the mu of t is there here. Is from the 0 to infinite, the value is 1. So infinite to the 0. Again, here the other integral is there. Expand that. The t into e power minus t a plus j omega whole divided by minus of a plus j omega minus into minus here the plus 1 by a plus j omega. After here also apply the integral here. A plus j omega whole square will get a plus j omega whole square, and the integral now it is whole square. The integral is a e power minus of t into a plus j omega. Okay, the upper limit is infinite and lower limit is a 0. First of all, you can substitute that t as infinite in the two terms. It becomes a value is a 0. And the 0, you can substitute the lower limit. The first term here, the t is at 0. And for the second term, already the minus is there here. The minus value, the minus into minus is a plus, and the other one is a minus also. For the second term, minus into minus will get the plus. The t is a 0 and e power 0 is a 1. So finally, we'll get the 1 by a plus j omega whole square. Okay. So for e power minus 18 mu of t, the Fourier transformation is 1 by a plus j omega. Whenever the t is multiplied for the function e power minus t into e power minus 18 mu of t, its Fourier transformation is a square. Its Fourier transformation is a total square, a plus j omega whole square. And the t is multiplied. Suppose if it is a t square by 2, t square by 2, the e power minus 18 mu of t, means it is increases. Here the t power 1 by 1 factorial is there, and the 2 factorial means 1 into 2. Its Fourier transformation is 1 by a plus j omega whole cube. And suppose the next one is t cube by 3 factorial is a 6. E power minus 18 mu of t. E power minus 18 mu of t. Its Fourier transformation is, see, whenever the t is power 1, here the square is there. The t is a square power 2, you get the cube, and t cube means 1 by a plus j omega whole power 4. Means it is increases here. It is a decreases. So finally, in terms of the n, we can write as t power n minus 1 by n factorial. N minus 1 by n minus 1 factorial. E power minus 18 mu of t. Its Fourier transformation is 1 by a plus j omega whole power n. So it satisfies the condition. If n is a 4, 4 minus 1 and the 4 minus 1. 3 factorial. It is also 2 factorial and is a 3 factorial. Okay. Write these as a 3 factorial. 3 factorial means a 6 only, my students. It is a 3 factorial and it is a 2 factorial and here it is a 1 factorial. So finally, the t power n minus 1 by n minus 1 factorial e power minus j t mu of t is a 1 by a plus j omega whole power n. Got it? If any value you will get the t square, t cube, t power 4 and t power 5, whatever it is there. It is a t power n minus 1 by n minus 1 factorial e power minus j t mu of. Okay. The same thing, the t is multiplied with the e power plus a t mu of t as also, you get the same. There is a 1 by a minus j omega as a minus. The square term is a positive value and the cube is a minus. And again here there is a plus value and it is a minus. Okay, because the minus e power plus a t mu of t is a minus 1 by a minus j omega. For the square, the value is a positive. For cube, the value is a negative. And for the even terms, the positive and the odd values is a negative. Okay. See here the same thing. The t into e power minus a t mu of t is a 1 by a plus j omega whole square. Got it, my students? Before to find the constant, the signum function also there. The signum function. Find the Fourier transformation of the signum function. I will explain here. Another example, signum of t. The x of t is equal to signum of t. Find the Fourier transformation. Find its Fourier transformation. So what is a signum of t signal? Showing that is plus 1 for positive value and for negative values it is a minus 1. Is nothing but the signum of t. Signum of t from 0 to infinite and minus infinite to 0. The t values. This is a graphical representation of the signum of t. Okay. So what is the definition of the Fourier transformation to find here? The x of omega is equal to, directly I am substituting here, integral minus infinite to infinite, signum of t into e power minus j omega t dt. So what is the signum of t? Is two parts we have. One is minus infinite to infinite 0. The magnitude is a minus 1. Minus 1 into e power minus j omega t dt plus the second part is integral 0 to infinite. The signum of t is magnitude is a 1. 1 into e power minus j omega t dt. Apply the integral here. Minus e power minus j omega t by, we are applying with respect to the t, the coefficient is a minus j omega. Upper limit is 0 and lower limit is a minus infinite. Similarly, for the second term also, the e power minus j omega t will divided by minus j omega. Here the limitations is from infinite to 0. Infinite and the 0. So first of all, you can substitute the e power 0 here, 1, and minus into minus is becomes a plus 1 by j omega. For the second term is a 0. And here, first term is a 0 because e power infinite is a 0. Second term is e power 0 is a 1. Whenever you can substitute the second term, it is a minus is already there. Minus into minus is a plus. 1 by j omega. Therefore, the Fourier transformation of the secant of t, the Fourier transformation of the secant of t is 2 by j omega. 2 by j omega. Got it, my dear students? So here the secant of t is 2 by j omega. Secant function, the 0 is a 1, and from the negative values is a minus 1. Divide the two parts of the integration, minus infinite to the 0 and 0 to infinite. The secant function Fourier transformation is 2 by j omega. 2 by j omega. Got it? Now, the x of t is equal to 1. X of t is equal to 1. Directly, you can substitute this as 1 e power minus at mu of t e power minus j omega t dt. According to the discrete condition, it is not satisfying. It tends to the infinite. It's always absolutely integrable. It's less than the infinite one. So by using the duality property, you can find out the Fourier transformation of 1. Before that, we have to know what is the Fourier transformation of the impulse function. Fourier transformation of impulse function. See first of all that Fourier transformation of impulse function. The example I am using here, that x of t is equal to delta of t. Find the Fourier transformation. Find its Fourier transformation. Delta of t. What is the graphical representation here? Delta of t is 1 at 0 at t is equal to 0 only. The remaining is all the zeros. Okay, directly I am substituting in the definition of the Fourier transformation. X of omega is equal to integral minus infinite to infinite delta of t e power minus j omega t dt. See, in this minus infinite to infinite, the delta of t having only the value is 1 at t is equal to 0. So, delta of t e power minus j omega t at t is equal to 0. The delta of t is 1 and e power minus j omega t is 0. Anything power 0 is a value is 1. So, x of omega is equal to 1. Means delta of t, its Fourier transformation is 1, my dear students. The time is impulse function. Frequency is constant 1. Now, how to find out the Fourier transformation of 1? Time is 1. What is the Fourier transformation? Frequency. What is the frequency? If time is 1, find the Fourier transformation. Find its Fourier transformation. So directly you can substitute in the definition of the Fourier transformation x of omega. It is integral minus infinite to infinite of 1 into e power minus j omega t into dt. If e power minus j omega t dt, can apply the integral e power minus j omega t by minus j omega. Upper limit is infinite and lower limit is infinite. So it is not satisfying according to the discrete conditions. So you go for the indirect method. That is delta of t, its Fourier transformation is 1. Its Fourier transformation is 1. Okay. 1 means this is a value of x of omega. Is a value of x of omega. Got it, my dear students. According to the duality property, What is the duality property saying? That capital X of t is equal to 2 pi into delta of omega, delta of minus omega, delta of minus omega, 2 pi into delta of minus omega minus. See, when here the delta, the time function is x of t is a delta function, the frequency is a 1. Frequency is the 1. So in the duality property, as omega is changes as a t and the t is changes as a omega, t is as a changes of omega, the x of omega is equal to delta of t here. The t is a 1. The delta of t, x of t is a delta of t. So x of omega is equal to 1 here. X of omega is equal to 1. And x of t is equal to delta of t here. X of t is equal to delta of t. But as a duality property saying that in the definition of x of omega is equal to integral minus infinite to infinite x of t x of t, it is not the delta of omega in the duality property. It is x of minus omega. X of minus omega. X of t into e power minus j omega t dt. This is the definition of the Fourier transformation. Interchanging of omega and the t, it becomes of x of t is equal to integral minus infinite to infinite x of omega e power minus j omega e power minus, it's not the, sorry, you will get from the inverse transformation, inverse Fourier transformation. X of t is equal to 1 by 2 pi integral minus infinite to infinite x of omega is a Fourier transformation, x of omega into e power plus j omega t dt, not the dt, d omega. Interchange omega and the t, it becomes of x of omega here, and cross multiply, it's at 2 pi, and change this omega as a minus omega, it becomes of integral minus infinite to infinite. X of omega is becomes a t, x of t, and e power t is omega, and omega is a t, and the value is a minus, so it is a j omega t, omega as a t dt. This is nothing but the Fourier transformation definition, but the pair is x of t, the Fourier transformation, x of t, the Fourier transformation is 2 pi into x of minus omega. X of minus omega. Let here, now this x of t is a 1. When this x of t is a 1, what is the x of omega? Will get here the delta of. When I am taking the 1 as a x of t, the time domain function, its Fourier transformation is 2 pi into, is actually the value is x of minus omega. X of minus omega, and this x of minus omega we get from the Fourier transformation of 1 for the delta of t. So the x values becomes a delta. 1 with the Fourier transformation is 2 pi into delta of minus omega. For negative values and the positive values, both are the symmetric only for the impulse function. So 1 with the Fourier transformation becomes 1 with the Fourier transformation is becomes a 2 pi into delta of omega. Delta of omega. Once again, I will tell, if x of t is a delta of t, the Fourier transformation is a 1. and 1 is nothing but x of omega. Since if it is a omega is changes as x of t and the t is changes as omega, means the 1 is a Fourier transformation, 1 is a time domain function, and the 2 pi into delta of omega by using this duality property. So 1, the Fourier transformation is 2 pi into delta of omega. It's a constant. The Fourier transformation is 2 pi into delta of omega. Got it, Madison? See here, delta of t, it's a Fourier transformation is 1. Here, x of omega is equal to 1. Means delta of t, the Fourier transformation is x of omega. According to the duality property says that x of t, the Fourier transformation is 2 pi into x of minus omega. Here x of t is a 1 and then 2 pi into delta of minus omega. Why I take the delta of minus omega? Then x of minus omega will be delta of minus omega. Why? When I'm taking the x of t is a 1, here the x of omega is a 2 delta of minus omega. Series, it is an impulse function. Delta of omega will be the even function of omega. Delta of minus omega is equal to delta of omega. Delta of omega minus omega is equal to delta of omega. 1 with the Fourier transformation is 2 pi into delta of omega. Okay, by using this duality property, my students. It's a very important. So today we discuss the Fourier transformation of e power minus at mu of t and e power plus at mu of t, and the Fourier transformation of e power minus a the magnitude of t, and the Fourier transformation of t into e power minus at mu of t when the t is multiplied. 1 by a plus j omega is there, and t is multiplied, it becomes of 1 by a plus j omega whole square, and so on. And the Fourier transformation of signum function, the 2 by j omega, and the Fourier transformation of impulse function is 1, and Fourier transformation of constant is 2 pi into delta omega. Got it? And it is a very, very important matter.